So if you want to write something like this in interval notation, so this is something that's going from -2 all the way to 12. So it's basically -2 comma 12. And then you look here, this side is closed, this side is closed, and that's pretty much how it looks. Now, here I have x is greater than -17. So that means on the number line, the values here will start on -17 and will go on forever. Because of this, there is an open circle here and it goes on forever. Okay, so another way to say that is the values that you're looking for start at -17 and they continue to positive infinity. Now, open circle gets a parenthesis versus a bracket. Infinity always gets parentheses, never a bracket, under no circumstances. All right, here, now, okay, so it's x is less than 3 or greater than or equal to 8. You can draw the number line. You don't have to draw the number line. I'm just showing it to you as a visual. So basically, the left-hand side, it's all the numbers starting at -infinity and going up to 3. So you say -infinity to 3. We don't say 3 to -infinity, by the way, okay? Never. You always start at the lowest value and go to the higher value. So -infinity to 3. And then I have 8 to positive infinity. Now, 8 needs a closed bracket. Okay, now, a few things here. Notice in problem B, I just put infinity. Here I put positive infinity. In the case of the positive infinity, it really makes no difference whether or not you put the plus. Now, before I take a question, in the middle of these two, we need this symbol. This is a union, and it means or. Okay? Is that your question? Yeah. The next one is x is less than 0, so it's all the numbers 0 to -infinity. So how would I write that? -infinity to 0. Okay? All right. So, all right, let's talk about functions. Again, this is just a review, so I'm just going to gloss over this one. A function is basically, it defines a set of numbers, okay? So that for each x value, how many y values can there be? 1. So think about that. Oops. For each x value, there can only be one y value. For each x value, only one y value. What happens if for one x value, there are 2 y values? Then it's not a function. All right, so that's what a function is. Okay, so, you know, we understand, we don't memorize the definition. For each x value, there can be one y value. Now, can there be, so if this is y equals 2, can there be 2 x values which have a y value of 2? Yeah, okay. So that works, but not the other way. All right. So, how do we, if you're given a representation of the function, how do you figure out if it's a function? Well, if you're given a set of ordered pairs, then no 2 different pairs should have the same x value. So you can't have the x values repeating and then, you know, with different ones. So you can't have 3, 5 and 3, 7. Graphically, it means no 2 points can lie on the same vertical line. And you already know this. We test it using the vertical line test, right? Okay, so let's go on and take a look here. Look at this function. Look at this relation here. Is that a function in A? Yeah, look at the x values. None of them repeat, so yes, it's a function. How about the second one, B? No, because these repeat and they have different y's. How about C? Yeah. How about D? Is it? Okay, so what you want to do is you want to solve for y. Let's solve for y. X over 2 is equal to y squared. And now if I take a square root, then what is y? Y is plus or minus x over 2. Okay? Root. Okay? It's not a function. Well, this, okay, so C is y equals x squared. This is x equals y squared. All right? So what is the function? What is the meaning of a function? No x value can have more than one y value. So it's plus or minus. So suppose x equals 1, then what's y? Y is plus or minus 1 over 2. That means for x equals 1, y is equal to half, and y is equal to negative a half. So for each x value that you put in, you get back 2 y values, and that can't be. Okay?
So y can never be squared.
Correct, in relation to x, yeah. Okay. Function notation, we know about this. So basically f of x like this is function notation. And it's written as and it's read as f of x. What that means, okay, what does that mean? F is the name of the function. X is the variable in the function. All right, so it doesn't have to be f of x. It can also be h of x. It could be v of t, okay? It could be r of s. Like, it could be a whole bunch of things. Each of those, like for example, v of t. Okay, here is a function. The name of the function is v. The variable inside the function is t. So, you know, based on your needs, you can use different variables. V of t is used most often if you're describing velocity with respect to time. Okay? All right. So, another way to look at it is f is the dependent variable. X is the independent variable. Okay. Another way to take a look at it is that value x in f of x, all of the x's that can, all of the values of x that can fit into that function define the domain of the function. All right. So x can represent any value in the domain. And once again, it's the independent variable. Okay? So you have the domain of the function. You put the domain values into the function. The numbers that are generated, those map out the range of the function. So y is the range, and it's called the dependent variable. All right. So take a look at this. Have we seen that before? Oh my. So when we had it before, it was f of x plus h minus f of x over h, remember?
Yeah.
So recall f of x plus h minus f of x over h, okay? The difference now is what? It's a. All right, so let's do a little bit of work in the margin here. F of x is given to me as x squared minus 2x. Okay, what's f of a? A squared minus 2a. Okay? Now, what's f of a plus h? A plus h squared minus 2a plus h. All right, let's take a look at that for a moment. All over h. Oh, no, sorry. I got carried away. Okay, so let's take a look at that for a minute. F of a plus h, f of x, and now we have f of a plus h. So if you just take this left-hand side, x got replaced by a plus h. So here, wherever you see an x, you're going to input a plus h. You're just going to substitute a plus h for all your x's. Now, of course, we simplify. So a plus h squared is what? A squared plus 2ah plus h squared minus 2a minus 2h, right? Okay, so then f of a plus h minus f of a over h, this is equal to, okay, f of a plus h, it's that blue part. Okay, minus f of a, so minus a squared minus 2a all over h. Okay, so now you, of course, have to distribute and simplify and all that good stuff. So we distribute the negative. What happens here? What happens to the a squares? A squares go away. What else can go away? The 2a can go away. Right, but that's a negative. So what do I have left? This is the cool part. So it's 2ah plus h squared minus 2h over h. Now what? Huh? Which square? Oh, it doesn't matter because look at what's going to happen now. What's going to happen now? There's going to be one h that comes out of each term. That's a thing. It's not a coincidence. Okay? That's the beauty of all this. Right, so now you have 2a plus h minus 2. Okay? And you can just leave it that way. In chapter 12, we're going to get rid of the h as well. Okay?
So you could take out an h.
You can take out each and the one on the bottom. Yeah. Right. There was a squared, and then here I distributed this negative, so it became a squared minus a squared. And then here it was minus 2a plus 2a. Okay? Yeah. Here, you see how it's the blue one? Minus, in parentheses, a squared minus 2a. So it's, okay? Yeah. All right. So now, we want, in this case, f of x equals 3. Okay, so first, in the top, in problem A, it was f of x equals x squared plus 2x. Yeah.
How did you know that f of x was like, that you replaced like x with a and not h?
Well, because what does the question ask for? The question calls for f of a plus h. Yeah, and f of a. Okay, so here, what we want now is, again, f of a plus h minus f of a over h. But now my function, f of x equals 3, this is my function. So 1, 2, 3. This is my function right there. Okay, so let's just take a look at this function. When x equals 0, what's f of 0? 3. What's f of 1? 3. What's f of negative 2? What's f of 100? 3. What's f of a? 3. What's f of a plus h? 3. Okay? Huh? Right. So, well, no, it's not 3. So this is, okay, so f of a plus h is 3 minus f of a is 3 over h. That's 0 over h, and that's 0. as it should be.
Why are we finding f of a plus h for
The question calls for this. The question calls for f of a plus h minus f of a over h.
Okay.
And now this is the function. We're done with that one completely.
No, yeah.
Uh-huh.
Find f of a and f of plus h.
Oh, you know what? I didn't even see that part. I just zoomed to this part. Yeah, so what would f of a be? 3. Right? And in this case, f of a was that one. Yeah, I didn't even see that one. I just, yeah.
I'm still stuck on the first one where you
Mm-hmm.
how did you get the answer you got for f a plus h?
Okay, so f of x is x squared minus 2x, right? Okay, so now that's f of x, and now we want f of a plus h. So forget about everything to the right of the parenthesis.
To get f of a plus h, it asks for the entire. No, because you needed nothing.
Well, you need to put it into that formula. What I was doing is coming up with each component individually and then putting it all together. I'm not going to do it that way all the time. You can do it all in one shot. Okay?
So can you explain how you got the a plus h squared minus 2?
Right. So now f of x was that we said, right? And now we want f of a plus h. So if we just look at the left-hand part, f of x to f of a plus h, forget about anything else. In going from f of x to f of a plus h, what happened? F is the same. X, though, got replaced with a plus h, right? So in this function, then, all x's need to be removed and replaced by a plus h. So it's not x squared, it's a plus h squared. 2 times a plus h, yeah.
So when you have one with two functions in it, you solve for each function first and then put them.
Well, we could have done it all in one shot. I find sometimes that confuses students more, so I do it separately. If you want to do the whole thing in one shot, you could do it in one shot. Okay? Okay. So, let's talk about domain. A function with an unspecified domain is called the implied domain. So, for example, if I just give you f of x equals x squared, and I don't say over the domain of blah, 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 then that implies a certain domain, okay? How do you figure out what that domain is? If I just give you a random function, f of x equals x squared, how do you know what the domain is? Well, basically, the domain is all the values of x, the independent variable, that when you put them inside the function, it gives you back real values, okay? So for example, if we do have f of x equals x squared, okay? If I put in a 1, do I get back a real value? If I put in 100, do I get back a real value? How about negative 100? Yeah. Is there any number that when I put it into x, I don't get back a real value? Not really. That means the domain for this is all reals. As opposed to, if I give you something like this, f of x is the square root of x. If I put in a 1, do I get back a real value?
Yeah.
If I put in a negative 1, do I get back a real value? No. So the domain then is all the numbers that give you back a real value. Okay, so rather than sit there and say, yeah, this works, yeah, that works, yeah, that works, yeah, that works, we look at what doesn't work for a function, all right? So what we do is we exclude values from the domain of a function that, okay, would result in division by 0, or if you're taking the even root of a negative number. Put it in layman's terms, what does that mean? You just have to make sure that the denominator isn't 0 and you don't have a negative instead of an even root. That's all. So that means we really have two types of functions that could be problematic for the time being. One is a rational function. Take a look at this first one. The top, there's nothing wrong with the top, but the denominator, I can't make that a 0. So what doesn't work for this one? Negative 2. But all the other numbers work. All right? That means all the numbers.
Well, what if you solve for it?
Well, that's what we're going to do eventually, like the more difficult ones. So negative 2 doesn't work. But all the numbers, negative infinity all the way to negative 2 works. And then all the numbers from negative 2 to positive infinity work. All right? How about the square root of x minus 2? So the problem there is I can't have the inside be a negative. So anything that's less than a 2 isn't going to work. Oops, that means it's everything starting at 2 and going to positive infinity. Okay? Oh, it does. You're right. Because when you put 2 in there, it does work. Of course, it's 0. Okay, so now, which one? The bottom one? Well, it's going to be all the numbers starting at 2 and going up, right?
What? 3 minus 2 is 1.
And the square root of 1 is? 3. Right.
3 is bigger than 2, so you're going up.
You're defining the domain, everything that works. You're defining, right?
I know we're finding things
Yeah.
that work.
Yeah. Okay, so now, when you have to find domain of a function, there are 3 possibilities. So you have to ask yourself, which of the 3 is it? The first possibility is polynomial functions. You guys know what polynomial functions are? You remember? They're basically numbers that have functions where the variable has exponents of integer values greater than 1. 1 or greater. Okay? So x to the 1, x to the 3, x to the 4. No roots, no absolute values, none of that crazy stuff. Here's an easy thing for you. The domain for polynomial functions is all real numbers, negative to positive infinity. Okay, so you see a polynomial function on the billboard walking down the street? Domain of all reals. Yeah. You have like a minute. Go and come back. All right. So here, is it a polynomial function? Yup. Domain, all reals. How about for part B? All reals. We are going to abandon this notation. Okay? It's all about interval notation. That's what the real life. Yes, we're growing up. Okay, so first it's polynomial. Next is rational functions with denominators. The domain of a rational function is every number except the zeros of the denominator. So, very easy. Take the denominator, set it equal to 0. It's factoring. Okay. So x plus 4. So basically, okay, the better way to write this, the better notation is, we can say x squared plus x minus 12 cannot equal 0. So this cannot equal 0. So now, okay, so now that it's a 0 product, right? We can say, okay, x cannot equal to negative 4. X cannot equal to positive 3. If you want to draw a number line for this, you can. You don't have to. So basically, all the numbers except for these two work. So what are my regions? Negative infinity to negative 4. That's this region. Union, negative 4 to 3. Union, 3 to infinity.
Could you also do negative infinity to negative 4, or negative 4 to positive infinity, and then do the same thing with 3?
No.
Oh, because it doesn't include the...
Right. The minute you say negative 4 to infinity, you're including 3 in there. Right. Right. Okay, all those. Okay, part B. The denominator, right? What can it not equal? T cannot equal plus or minus 1. That means it's what regions?
Negative 1. I mean, negative infinity.
Negative infinity to negative 1. Negative 1 to 1. And 1 to infinity. Okay. What about here? Mm-hmm. Right? If we had to do a common denominator here, it would be x plus 8, x minus 10, right? So x cannot be negative 8 or positive 10. So negative infinity to negative 8. And then you have all the numbers from negative 8 to 10. And then 10 to infinity. If it confuses you, draw a number line. So negative 8 and 10 don't work, but everything in the middle does. And everything to the right and to the left will work. All right, what about next one? For what values is that denominator 0? What happens when I put 1 in for x?
Doesn't work.
Doesn't work, meaning what?
You want to make that negative 1.
Where is that equal to 0? I is not a real number. We want the real numbers. So basically, what are you doing here? You're taking a number, you're squaring it, now you made it positive, and then you're adding 1 to it, so you're increasing it. That means this can never equal 0. All right? So no values. That means the domain is negative infinity to positive infinity. Okay? Because the denominator, there are no values for which the denominator is 0. So anything works for this function. Yeah. Any real number. Yeah. Right.
There's no values where it doesn't.
Correct. Yeah. So we did polynomial functions, we did root functions. I'm sorry, we did polynomial and rational. Now the third is radical functions. Okay. Radical functions can also be split into two. If you have an even nth root, square root, fourth root, sixth root, the radicand, the stuff inside, has to be greater than or equal to 0. Okay? If you have an odd root, cube root, what's the cube root of 1? 1. What's the cube root of minus 1? Negative 1. So cube roots, fifth roots, seventh roots, odd roots have no problem. All numbers work. So the domain of odd roots is all real numbers. I know. So this one here, right? You go inside and basically you want that to be greater than 0. Okay? So yeah, so 7x has to be greater than 70. X. Right. So this shouldn't say, right, it could be greater than or equal to 0. So yeah, it should be greater than or equal to, sorry. So that means my domain is all the numbers greater than 10, which is 10 to infinity. Okay. Let me skip B for a minute. How about C? All real numbers. All right. Okay, let's go to B. You want x squared minus 2x minus 15 to be greater than or equal to 0. Okay? Remember from algebra 2, we factor this. What do I get when I factor? X minus 5, x plus 3, greater than or equal to 0. Now what? Yeah.
be anything less than -3 and everything greater than 5.
Okay, how do we know that? We need to do a number line. So we have -3 and 5 on the number line. Now, pick a representative number from the region on the left. So something smaller than -3. -4. If you plug -4 in here, you get negative times negative positive, right? Pick a number between -3 and 5. 0. If you plug 0 into the parentheses, you get negative times positive, negative. And if you pick a positive, a number greater than 5, you get positive everywhere. So for which region do we get positive values? Below -3 and above 5. So it's, yeah. So this is a split domain. Okay. If you pick a number like -10 and you plug it in this, you get a positive value. So that works. Okay. Oh my, what the heck is this? To the power of 3/2? That's the square root of 9x minus 2 cubed. So, if you get a negative value for 9x minus 2, you cube it, you get a negative value. Does that work? Yeah? Yeah. Yeah? Okay, so if x was 2, I'm sorry, if x was -1, okay? Or what do you get for inside here? Negative, right? And then you cube it and you get negative. Let's work with a smaller number. What if x is 0? Then here you get -2 cubed, which is -8. And then it's the square root of -8. That doesn't work. So I still have to make 9x minus 2 greater than or equal to 0. So x is greater than or equal to 2/9. So my domain is 2/9 to infinity. Okay? Okay, so at 2/9, right? At 2/9, what value will this take on? 0. Can you have the square root of 0? No. Or yeah. You can. So you can use that one. So basically, if it's in the denominator where you cannot have a 0, it's going to be a. So it just means you can use that one too. Right. Okay. Take a look at this one. Oh my. All sorts of stuff here. Okay, so first of all, we have a root and it's in the denominator. Okay, so this is a root and it's in the denominator. So root means it has to be greater than or equal to 0. Denominator means it cannot equal 0. So it has to be strictly greater than 0. Okay? So then x plus 2 has to be greater than 0. X is greater than -2. So that. Okay? Huh? I know. Take a look at this one now. The denominator has to be greater than or equal to 0. I'm sorry, that was the numerator. The denominator cannot equal 0. Okay, let me. Well, it is if it's a root. Okay, so here x minus 3 has to be greater than or equal to 0. So x is greater than or equal to 3. Okay. Let's just draw that. 3 and above. Okay, what does that denominator say? X cannot equal 6. That's the one. So yeah, the numerator said, all right, everybody above 3, come on in. And then the denominator says, no, leave out the 6. Okay, so no. 3 to 6. Now, where do I close? Where do I open? Close the 3, open the 6, and then? Okay, tell me that's not amazing. Come on. Tell me that's not exciting.
You wouldn't do infinity because that's included in these two, right?
Correct. Then 6 would also come along. Yep. It's the opposite. Yeah. Because if you do 3 to infinity, you're also including the 6. I know. This is everything against what D Toledo stands for as far as like being all inclusive. We're just shutting people out here. Okay. Take a look at this one. Any problems with the numerator?
Yeah.
No, it's a polynomial function, all reals. It's got to pass.
Yeah.
Any problems with the denominator? What can it not equal? Plus or minus 1.
Negative
2.
-1. And then the union -1 to 1. And then 1 to infinity.
Any issues with the numerator for H? No. Polynomial function gets a free pass. It's fine. What about the denominator? So, okay, 2x minus 3 greater than or equal to 0? Huh? It can't, okay, so greater than 0. All right? It would have been greater than or equal to 0 if that root was in the numerator. But since it's in the denominator, it has to be greater than a 0. It cannot equal 0 either. So x is greater than 3 over 2, strictly greater. So 3 over 2 to infinity. Oh my God, I love these. They're not as exciting as trig, but man, I guess I miss them. Okay. Piecewise function. We remember this from last year?
Oh, I keep doing these on Alex. I keep getting them wrong.
Okay, well, that will change now. Okay. Piecewise functions are defined in pieces. And there is always a region where you have one function and then another region where you have another function. This stuff on the right with the inequalities have nothing to do with the way the graph looks. All it does is defines the region, the field, where each function will exist. So the top function will only exist where x is less than 0. So here, okay? So here, the other function will only exist where x is greater than or equal to 0. So we have region 1, where we're going to graph function 1. We have region 2, where we're going to graph function 2. Let's graph function 1. You can do it any which way. One thing that you've got to do, okay, is plug in boundary points. Where is the boundary here? Nope.
0.
At x equals 0. The boundary splits at x equals 0. You have less than 0, greater than 0. So we plug in x equals 0 to the top function. So at x equals 0, f of 0 is 2. So at x equals 0, this is 2, the purple function. Okay, this is, oh yeah. Hang on. So it's 2. Now, take a look here. You see how it's x is less than 0? That's an open circle. So at 2, I do an open circle. It doesn't have to be that big. Now, the function is negative x plus 2. Visualize it. What does it look like? Line, parabola, circle, what? Line. Going up or going down? Down. What is the slope? Negative 1. So you can just draw a line with a slope of -1. Okay?
Wait,
Waiting. What am I waiting
I
for?
don't understand why that goes down.
why is it up? Is negative-
One is asking me why is it going down, one is asking me why is it going up.
No.
From-
You
You
said
read it this way.
It's negative x plus 2. The slope is a -1. That means the function has to decrease. Okay, I drew it that
Oh,
way,
okay.
but
Is there an arrow going this way?
I don't do arrows. You can, but I
It
don't.
would continue on that.
Yeah, it would.
Okay. Why isn't it going
Did we do an arrow to get
down?
Okay, this function is only allowed to live when x is less than 0. This is x is 0. This is the region, the interval where x is less than 0. Now, the second function is only allowed to live over the interval x is greater than or equal to 0. So it only lives on this part. You've got to plug in 2. So, for function 2 you've got to plug in 0. At x equals 0, y is 2. Is it open or closed? Closed. Now, if you have an open and a closed overlapping, you just close it. That's it. Okay? And then what does that look like? It's a parabola that goes up, so it looks like this. Okay? Now,
you don't have to be precise.
no. I'm going to stop here. You can do most of this, okay? So please do the homework. I'll specify on haiku which ones for Thursday, okay?